Salam, peace be upon you. My name is Muhammad Laik Siddiqui, the father of Holophase. Recap of our journey, parts 1 through 28. We began by putting pattern before object. Phi gave us primitive circular comparability, and we learned that only relations are public. From there, we disciplined claims. Every claim must declare its type, scope, assumptions, and window. We learned how local change is read through lifts and the carrier A equals D of phi tilde, how finite jets record local signatures, and how cadence, texture, and flow are three readable faces of one pattern. Domains, excisions, aliasing, and boundaries became part of identity. Local charts stitch into global memory through winding, holonomy, and defects. Identity is invariant equivalence under declared transforms. Persistence is certified survival. Null is the honest verdict when nothing is certifiable. Orientation and reversal required bookkeeping. Interaction became joint constraint, composition became conditional, laws became coexistence boundaries, and dynamics became lawful transformation with derived order. Conservation, generation, and provenance. How we keep honest books of what persists, what appears, and where every claim came from. There is a moment in every serious science when we realize that change is not the hardest word. The hardest words are same, new, and came from. Because the moment we start talking about dynamics, about patterns transforming, our language becomes dangerously easy to inflate. We can say a new structure emerged and everyone nods. We can say something was conserved and everyone nods. We can present an equation and everyone nods even harder. But nodding is not certification. So in this part, we install the bookkeeping layer that stops our story from turning into theater. We install three inseparable disciplines: conservation, what persists across lawful transformation; generation, what appears lawfully but never from nothing; 3. Provenance, the lineage graph of every public claim, how it was produced, from what sources, through what transformations, under what conditions. This is one integrated chapter because these three are one logic. If we say something is conserved, we must say under what transformation family. If we say something is generated, we must say from what source structure. If we say anything at all publicly, we must show how the claim came to be. That is what it means to keep honest books. 1. The two questions that make change intelligible. When we watch a transformation, any transformation, from a melting ice cube to a collapsing star, we usually ask one question: what changed? But that is only half of dynamics. The other half is what makes the change intelligible at all. What stayed stable enough to recognize that a change occurred? Change without continuity is noise. Continuity without change is stillness. Dynamics is the weaving of both. So the first discipline we install is a dual question we must ask every time we certify a transformation. What remained invariant enough to carry identity through the change? What new structure appeared that was not present before in that form? Those are conservation and generation. A simple everyday story: baking bread. We can learn this entire chapter in a kitchen. We start with flour, water, yeast, and salt. We mix, we knead, we wait, we bake. What is conserved? Not the shape, not the texture, not the smell. Those all change. But some things persist. The basic chemical matter does not appear from nowhere. The ingredients transform, redistribute, and reorganize, but they do not become nothing. What is generated? A crust, air pockets, a stretchy gluten network, aroma, a new edible structure. And here is the key: Nothing appeared by magic. The gluten network comes from proteins in flour plus water plus kneading. The air pockets come from yeast producing gas. The crust comes from heat-driven transformations at the surface. Bread is a perfect illustration of our rule. New structure can appear, but it must be traceable to prior structure through a declared transformation under declared conditions. That is generation with source accounting. 3. Conservation, what it really means. In our framework, conservation is not a mystical fluid that stays the same. It is not a force. It is not a moral rule of nature. It is bookkeeping. Definition, pattern level. Conservation means invariance across a declared family of lawful transformations. Read that slowly. Declared family means we must say which transformations count. Lawful means we are inside certified rules and scope. Invariance means the same value, structure, or equivalence class persists across the transformation. So conservation is always relative. A thing can be conserved under one family of transformations and not conserved under another. The forms of conservation we must be able to name. To keep our books honest, we must distinguish kinds of conservation. Otherwise, we confuse sometimes stable with always stable, or stable at one scale with stable at all scales. Strict conservation. Conserved across every transformation in the declared family within scope. Example. In many physical settings, total electric charge is treated as strictly conserved. Within the declared system and rules, we do not permit charge to appear from nowhere or vanish into nowhere. Conditional conservation. Conserved only when conditions hold. Example. Mechanical energy may be conserved only when friction is negligible. If friction matters, mechanical energy is not conserved, but energy may still be conserved in a broader accounting that includes heat. Conditional conservation teaches us discipline. We must state conditions, not just chant conserved. 4.3. Emergent conservation. Not conserved in the tiny details, but conserved at a higher level of description. Example, a crowd looks like a flowing fluid at a distance. At that scale, conservation laws can hold cleanly, even though each individual person makes irregular choices. Emergent conservation reminds us conservation can be scale dependent. 4.4. Topological conservation. Conserved because the global structure cannot change without tearing or restitching the pattern. Example, the number of holes in a donut is conserved under continuous deformation. We can stretch, twist, and squeeze, but to change the hole count, we must cut and rejoin. Topological conservation matters deeply in Phi Pattern science because winding, holonomy, and defects are precisely these cannot change without breaking the rules structures. 4.5. Scale-specific conservation. Conserved at one scale, not conserved at another. Example, in a city, total number of cars might be conserved over a short time window in one district, but not over a day as cars enter and leave. Conservation depends on boundary conditions and scope. Scale-specific conservation forces us to declare boundaries and domains. 5. A cross-scale example, the water cycle. The water cycle is a cathedral of conservation that also teaches why scope matters. At the planetary scale, water is largely conserved. Water changes form, ice, vapor, liquid, but does not appear ex nihilo. At the local scale, a lake loses water by evaporation and gains water by rain and rivers. Water is not conserved locally unless we include those boundary flows. So the same phenomenon teaches the same rule. Conservation is not a slogan. It is a certified statement inside declared boundaries, domains, and transformation families. 6. Generation, what it really means. Now we turn to the other half. Generation is the word that invites myths. It is the word that tempts us to say something came from nothing, so we discipline it. Definition, pattern level. Generation is the lawful appearance of new pattern structure from source accounted prior structure. Generation is real. New structure can appear, but it is never free. It must be paid for in bookkeeping. 7. What generation is not? If we do not say this explicitly, we will smuggle novelty by language tricks. Generation is not relabeling, renaming the same structure, reparameterizing, changing coordinates or representation, canonicalization, producing a standardized form for comparison, discovery, noticing what was already there but previously illegible, storytelling inflation, calling a small rearrangement radical emergence. Generation is only generation when new certifiable structure appears that was not present before in that form, and when we can trace it to sources through lawful transformations. A simple story of generation, the snowflake. A snowflake appears in a cloud and it looks like pure novelty, but it is not magic. Source structure, water vapor, temperature gradients, humidity, nucleation sites, airflow patterns. Transformation, vapor deposits into solid crystal growth. Preserved invariance, the chemical identity of water molecules. Lost structure, the random freedom of vapor motion. Generated structure, stable crystalline symmetry, branching geometry. Everything is accounted. That is lawful generation. This is how we must speak about novelty, not as miracle, but as traced structure. 9. Source accounting, the rule that prevents magic. Now we install the central discipline. Whenever we claim generation, we must answer 1. What prior structures were the sources? 2. Which lawful transformation produced the new structure? 3. Which boundary conditions or couplings enabled it? 4. What was preserved? 5. What was lost or redistributed? 6. What exactly is the new certifiable structure? If we cannot answer those, we do not certify generation. We refuse it. This is not pessimism. It is the minimum honesty required for public science. 10. The absolute rule at this certification layer. No ex nihilo. Now we state the firewall that locks the entire framework against myth. No ex nihilo at this certification layer. Meaning, we do not certify claims that pattern structure appears from nothing. We do not certify claims that pattern structure vanishes into nothing. Every appearance must be traceable. Every disappearance must be accountable. This is not a metaphysical decree about reality. It is a public knowledge discipline. It means if our accounting cannot find sources, we do not pretend we have explained anything. 11. Disappearance must also be accounted for. People often think only new appearance needs discipline, but disappearance is an equal danger because it lets us hide losses. If a pattern is no longer certifiable, we must ask, did it transform into a different pattern? Did it leave the domain through boundary flow? Did we excise the region? Did we coarse grain and lose detail? Did it become illegible due to resolution, noise, or missing access? If none of these are declared, disappearance is not explained. It is smuggling. Everyday example, salt dissolving. The grains disappear, but they do not vanish. They transform into dissolved ions. The visible crystalline pattern is lost. A new distribution pattern appears. The loss and appearance are both accounted. That is what we require everywhere. 12. The pattern conservation principle. Now we can state the principle that unifies conservation and generation. Pattern structure does not appear from nothing nor vanish into nothing without lawful transformation. Every appearance must be traceable to prior structure. Every disappearance must be accountable through transformation, boundary flow, excision, coarse graining, or legibility loss. This principle does not make the world smaller. It makes explanation real. It is one of the deepest anti-smuggling rules because it blocks the easiest escape route. It just emerged. It just disappeared. It just happened. We do not allow just in public science. 13. Why this is the deepest anti-smuggling rule. Without this discipline, we can always cheat. If we cannot explain where something came from, we call it emergence. If we cannot explain where something went, we call it dissipation. If we do not want to declare assumptions, we hide them in obvious laws. If we do not want to show our pipeline, we present only a final equation. So conservation and generation are not merely physical topics, they are epistemic security. They protect the framework from turning into a mythology of newness. 14. The gates we must install. Because this is public science, we must be able to refuse claims cleanly. 14.1. Conservation gate. A conservation claim must declare the invariant being claimed conserved, the transformation family across which it is conserved, scope and boundary conditions, what would falsify the conservation claim. 14.2. Generation gate. A generation claim must declare the new structure being claimed generated, why it is genuinely new, not relabeling or canonicalization, the transformation that produced it, the conditions under which it appears. 14.3. Source accounting gate. A generation claim must include source structures, prior states, prior claims, prior artifacts, the pipeline from sources to result, where losses occurred and why, what was preserved. 14.4. Loss declaration gate. Any disappearance, simplification, or reduced legibility must be declared. Excisions, coarse grainings, boundary exits, sensor limits, missing data. 14.5. No ex nihilo gate. Any claim that implies from nothing or to nothing is refused unless the accounting is corrected. These gates are not bureaucracy, they are the skeleton of honesty. 15. The outputs of Part 28, what we now possess. By the end of conservation and generation, we possess a disciplined concept of conservation as invariance across declared lawful transformations, a disciplined concept of generation as lawful sourced appearance, a prohibition against ex nihilo at this certification layer, lineage sensitivity. Once sources matter, histories matter. And once histories matter, we reach the next inevitability. Provenance must become first class, because a claim without history is a claim without publicness. Why provenance must become first class? Here is the simplest truth. A public claim is not only what we say. A public claim is also how we got there. If we publish content without lineage, we create orphan claims. Orphans drift. Orphans cannot be corrected cleanly. Orphans cannot be audited. Orphans become myths with footnotes. So we install provenance as part of claim structure itself, not optional metadata. What provenance includes? To make provenance real, we must name its contents. A claim's provenance must include source claims, The parent claims this claim depends on source artifacts, data, measurements, proofs, logs, simulations, or records. Transformations applied, the operations that turn sources into the new claim. Parameter settings, thresholds, tolerances, smoothing choices, model settings. Selection decisions, what was included, excluded, filtered, or ignored. Toolchain context, which software, which version, which implementation choices. Random seeds, if stochastic steps exist, where randomness entered and how it is controlled. Certification history, prior approvals, refusals, downgrades, migrations, supersessions. Version context, which standard or constitutional version governed the claim. This looks long, but it is simply the adult form of one question. How did we get this? 18. Provenance as a lineage graph, not a footnote. Provenance is not a paragraph at the end. It is structure. We represent it as a directed graph. Nodes are claims and artifacts. Edges are transformations and decisions. Certificates and refusals attach to stages. Parameters and toolchain identifiers decorate edges. This graph is part of what the claim is, because if the lineage changes, the claim's identity context changes. Two claims with the same sentence but different provenance are not the same public claim. One may be well-founded, the other may be accidental. 19. Why provenance makes correction, revocation, and trust possible. Without provenance, derived claims drift silently from parent claims. Corrections cannot locate what changed. Migration across versions becomes guesswork. Revocation cannot propagate through dependencies. Audits cannot replay the pipeline. Hidden toolchain dependence becomes invisible. Selection smuggling becomes effortless. With provenance, every derived claim carries its ancestry. Errors can be localized. Responsibility can propagate. Public disagreement can become precise. Provenance is the bridge from knowledge as stock to knowledge as certified structure. Provenance as a condition of publicness. This is the deep line we must accept. A claim may be interesting without provenance, but it is not fully public in the strong certification sense. Because publicness means replayability by strangers. If strangers cannot reconstruct how the claim was produced, the claim is not fully public. So provenance is not administrative, it is epistemic. The gates for provenance. To make this enforceable, we install gates. Provenance gate. Every public claim must point to a provenance record. Lineage integrity gate. The lineage graph must not have broken links. Parents must be identifiable. 21.3 Toolchain gate. Tool versions and implementation context must be declared where they matter. 21.4 Selection declaration gate. Data inclusion and exclusion decisions must be declared. 21.5 Seed branch gate. If randomness exists, seeds and branching policies must be declared. 21.6 Version gate. Claims must declare which standard version governed their production. These gates turn provenance into a real public requirement. 22. Firewalls against the new forms of smuggling. As soon as we demand provenance, new smuggling attempts appear, so we block them. We forbid claims with no ancestry when ancestry is required. Silent preprocessing drift. Blackbox tool did it without declared settings. Hidden selection. We only kept the nice data. Private pipelines behind public verdicts. Corrections that break lineage continuity. If any of these occur, we refuse certification. What Part 28.5 installs? By the end of provenance, we have installed provenance as a first-class claim field, lineage graphs as part of claim identity context, derived claim accountability, the infrastructure for correction, migration, and revocation, the first real form of civilizational method memory at the claim level. Now our science has what most sciences lack: memory that is not merely social, but structural. Refusal conditions, the lines we will not cross. We refuse conservation claims without declared invariants and transformation families, generation claims without source accounting, disappearance without an account, any suggestion of ex nihilo at this certification layer, any public claim with materially missing provenance, any derived claim with unknown parents, any pipeline that cannot be replayed or audited. Refusal is not harshness. Refusal is the price of publicness. We can end this part with one image. Imagine we are accountants of reality's patterns. On one page, we record what stayed the same across transformation. That is conservation. On the next page, we record what appeared and where it came from. That is generation. On the final page, we keep a family tree of every claim: parents, transformations, parameters, tools, and decisions. That is provenance. Without these books, change becomes a story people enjoy. With these books, change becomes a structure strangers can verify. And now we are ready for the next inevitability. Once lineage is first class, we must face branching uncertainty honestly. Randomness, stochasticity, and probability as certified readouts rather than mystic fog. That is the road ahead. Always peace be upon you.